Hello and welcome back, the students. This is in continuation to your online down classes, and we are on the second last chapter of the theory class, which is chapter 9. This chapter is about basics of payloads. In this chapter, we shall be learning about the different types of payloads which are currently being used by the drones, and we will also look into the features and the capabilities of such payloads. So let's begin this session. Payloads. What is a payload? A payload can be defined as it is an extra weight that a drone can carry in addition to its own. So payload is never counted in the drone's weight. The drone weight is about the weight of the airframe, which is the structure, the battery, which is the power unit, and payload is the capability which a particular drone can lift a particular component of a given weight. The payload can be anything from a camera or a sensor. It could be a package, as well as it could be in a military and defense. It could be a weapon or a missile. So there are different types of payloads. Payloads determines the capability of a particular drone, and it defines what task that drone can perform. So let us look into the types of payloads. There are some common types of payloads for the drones, and the number one at the list is camera. There are some cameras which a drones can carry for aerial photography or videography. These cameras are equipped with various types of lenses and also sensors. It depends upon which particular mission they are designed for. The sensors could be a thermal sensor. It could be a LiDAR, which is a light detection and ranging sensor, which uses a remote sensing technique. And there are some other types of sensors as well. And these sensors enables the drone to perform survey and mapping, monitoring, and various other similar types of tasks. The another third one on the list is a delivery package. Drones can be used for delivering the packages and can carry the payloads, for example, medicine, food, or maybe some other items. The next in the list is the communication equipment. Drones can carry the communication equipment in the event of emergency situations, and it can also take the communication equipment to remote locations where there is no network lights, and the drones can be placed from location to location so that they can help each other to connect and transfer the data from far distance. In military and defense, only UAVs are permitted to carry the weapons, and those payloads can be a missile or a bomb. So no civilian drone should carry such equipments. Okay. Types of imaging payloads, which are basically the cameras we have just observed in the previous slide. The camera is among the major payloads which the present drones are carrying to perform various photography and videography. Various types of operations like mapping, survey, crop health monitoring in agriculture. So let us first have a look at the RGB camera, which is the very common one. The smartphones that we use has a camera, and that is actually the same RGB camera. So how these cameras works, which are RGB cameras? They captures the visible light, having the wavelength that ranges from 400 nanometers to 700 nanometers across three primary colors, that is red, green, and blue. Let us look into the functionality of RGB cameras. In RGB camera, the generation of the image is done by the combination of base colors, which are red, green, and blue. Such cameras has a sensor with it, inside it, and the sensor has a pixels. Now, each pixel in this sensor will have further three different types of subpixels, each of which can sense only one particular color of light. Okay, and so you can say the sensor of this camera has a capability to sense only the intensity of a certain spectrum of light. Okay. Now, this data which a sensor generates, this data is converted into the electrical signals, maybe in the form of voltage, you can say. And this signal is then further processed by a processor, which then further displays the image on the screen. Okay, so this is how RGB camera works. We have already discussed that it is used in mapping, surveying, and surveillance. The second type of camera is the thermal cameras. A thermal camera is designed to detect the radiations with greater wavelengths, up to 14,000 nanometers. Okay, we know in the electromagnetic spectrum, it is only the visible light that the human eyes can see, right? And those visible light has a wavelength ranges from 400 nanometers to 700 nanometers. But in thermal cameras, it can detect the radiations which are up to, you can say, or around 14,000 nanometers, which are normal human eyes cannot see. But they are also you can say light radiations only. Okay, so how these cameras works? These cameras works by detecting and measuring the infrared radiation which are emitted by the object. So every object is actually emitting a radiation which is an infrared radiation. Okay, and this infrared radiation is due to its body heat, the temperature, because every object has a different temperature, and this can be sensed by the thermal cameras by working in the range of infrared radiations. So it records the temperature at each point in the image, and then it displays as a color-coded image. So in the image, the hotter areas will appear in the brighter colors. You can say it will be in the darker red colors, and the cooler areas in the image will appear in the lighter colors, you can say. Okay, the darker colors. Okay, darker colors like blue. Okay, so this is how thermal cameras functions, and there are various benefits of using thermal cameras. The advantage is they can capture the image in complete darkness. Even when there is no light, the cameras can still generate the image with much detail just because of sensing the temperature on different parts of the particular object. So they do not rely on the visible light. We can see there is an image, and this image shows how the particular house is showing the heat lost regions. Okay, the image is very much exactly revealing the hidden heat which this house is losing through its different watts, different surfaces, and these things cannot be seen by the normal human eyes. So applications, these cameras are ideal for operations like search and rescue, building inspections, the example is in front of you, and wildlife monitoring. The another type of imaging payload which a drone camera carries are the multispectral cameras. You can see there is an image on the right is a multispectral camera. It functions by capturing the images in multiple wavelength bands. So it is like not just capturing the band which belongs to a visible light, 400 to 700 nanometers. This multispectral camera can capture the image in the wavelength which is far low than 400, maybe 70, you can say, and it can capture the wavelength of the light that belongs to the range of you can say which are near to the infrared or thermal infrared as well. These cameras have special sensors, or you can say filters, to capture the image in different wavelength bands. These can range from ultraviolet, the UV. We know there is the UV is this particular spectrum of light that has a very low wavelength. Okay, there is a X-rays, gamma rays, then X-rays, then UV rays. Then we have the range which is a visible light. Okay, then we have infrared, and this is followed by radio waves. Okay, so this is all about the multispectral cameras. In this camera, each wavelength band captures unique information about the such as the presence of certain chemicals with or the physical properties can also be revealed. Once the images are captured, they are processed to correct for distortions. Various unnecessary details are removed to enhance the quality of the data, and this process can include the geometric correction, radiometric correction, and spectral calibration. And after that, the images are combined and further processed to create a single multispectral image. The applications of multispectral cameras are to monitor the health of the crop, soil moisture levels can also be identified, the water quality, and there are other environmental factors as well. So we can see how much useful these multispectral cameras are, because they can give you a detail which can help you a lot to optimize your let's say the farming approach and various other activities. There is another kind of payload which is known as lidar sensor. Lidar sensors are also now gaining popularity because of its very good capabilities. LIDAR stands for light detection and ranging. These sensors are remote sensing devices which are used by the drones to create a three-dimensional map of any object or the terrain or the environment. Okay, these sensors use the laser pulses. They sense the laser pulse which measures the distance, and then as per what time these pulses have taken to reflect back from the objects. So this can help them determine the details, the distance, and the pattern of the terrain. Okay, and this information then further can be used to create a point cloud of the surrounding environment. Okay, the next type of payload is the hyperspectral cameras. These hyperspectral cameras works in the similar way as the multispectral cameras, but the capability of hyperspectral cameras are far ahead than multispectral because they can carry the more wider bandwidth. Okay, and again it can be used for agriculture, geology, remote sensing. Okay, the another type of payload is the gimbal. The gimbal is also a payload because these cameras are not just simply fixed on the drones. These cameras are fixed on the gimbals, and which further connects with the drone frame. What is this gimbal? A camera gimbal is a device which helps stabilize a camera or other payload which is mounted on the drone, and this can generate a very stable image, very stable video. This gimbal is consist of the motors and sensors. It has a gyroscope to detect and compensate for the movement of the camera and the drone. So it can adjust the camera and fix it to a stable angle, which is that remains undisturbed by the movements of the drones during flight. And this camera can stay focused on a particular object just because of this gimbal, no matter in which direction the drone is turning or moving. The camera will remains its focus on a particular subject. There are different types of gimbals which are available in the market, but the most common and the most the best one is the one which consists of three axes: the pitch axis, a roll axis, and yaw axis. In the figure, we can see the camera is shown to be mounted over a gimbal, and gimbal has three axes. One is the pitch, a roll, and yaw. But in the image we see the names pan axis and tilt axis and roll axis. So what are they? Let's learn about this. This gimbal controls the movement of the camera about pitch axis. Pitch axis means rotation of the camera, which is up and down rotation actually. The up and down rotation of the camera. Okay, and the camera is like this. So camera is coming up, coming down. So this particular rotation is referred as pitching motion of the camera, and in the field of this photography, the photographers call this pitching motion as a tilt motion. Okay, then we have the another axis, which is the yaw axis, in which the camera can be rotated by the gimbal in this direction. Okay, it can be turned like this, directional movements in the left and right. So this particular yaw control is called as PAL motion of the camera in photography. And then we have a roll where the camera is can be rolled like this, and about the rolling axis, and this is known as the roll motion, the rolling motion of the camera. So by controlling these three axes, the gimbal can keep the camera in the stable position. What are the benefits of using a camera gimbal? We have just seen a gimbal helps produce smoother and more stable footage. Okay, the camera can stay level and steady even in the windy or turbulent conditions. As there could be a situation that a drone pilot is flying his drone and the weather is very windy and turbulent. That time there could be a lot of vibrations in the drone that can affect the quality of the photograph being taken. But this gimbal will place its flow and it will, he will just leave that. Well, benefits of using a camera gimbal. So we have just noticed that a gimbal is helping the camera to produce a very stable and quality image. Right? It can make the camera to stay level and steady even in the windy conditions as well. So whenever a drone pilot is flying his drone and there are some uncertainties with respect to the weather conditions and the wind becomes turbulent, this can lead to the vibrations on the drone, which can further affects the quality of the photography or the video which the camera is taking. So in that trial, the gimbal will help the camera to stay stable, and it also increases the flexibility in camera positioning. Weight versus flight time. Now, weight and flight time are very much connected with each other, because in case of an aircraft, the designers pays lot of effort just to ensure that their aircraft's weight is not at a level where it is draining the lot of power from the propulsion system, and the weight should be kept at minimum for a better performance, because it is only the weight which an aircraft has to the aircraft has to come over, right, against the gravity. So an extra weight that a drone carries will consume extra power from the battery, and also higher the power to weight ratio of the drone, the greater will be its capability to carrying a payload. So power to weight ratio should be as high as possible for the drone. Now, after learning about the different types of payloads, their features, it becomes now very easy to understand which are the parts, which are those things that are going to be a part of the payload. Because when you want to mount a payload, you need a payload mount. Okay, camera has to be mounted on a gimbal, right? And then gimbal has to be attached, so it needs a payload mount, and sometimes the power source for the payload is different than the power source of the drone, so that its flight time is not much affected. So sometimes a drone's payload may have its own power supply that is going to be a part of the payload in that case. the data connection links which payload will be transferring. Okay, with the flight control boats and then sending it to the ground control stations, right? There could be various sensors on the drone, like LiDAR sensors, right? And the enclosure for the payload safety. Sometimes the drone's payload has a special enclosure so that its functionality does not get affected by the, let's say, the dust and dirt and various other elements in the atmosphere. Right. Enclosure also protects the payload in case of any drone crash or an accident. So that is why enclosures are very important part of the payload. So these were the parts of the payloads. Now, next is about features of the payloads. We have seen high resolution imaging is one of the feature. Real time data transmission is the another. Autonomous operation, lightweight and compact, plus integration with the drone flight control systems. Drone payloads are fitted in such a way so that it integrates with the drone flight control system, and this allows further the drone pilot to control those and actuate the payloads in use during the drone flight. Okay, so these are the features. Then we have a multiple sensor capabilities and power efficiency. The payloads must be power efficient, should not be the one which is draining all the power for the throw all the time, even when not required. Okay, so these features should be kept in the mind while deciding the type of payload for installation on the drone. This was all about the basics of payloads, the different types of payloads, their features, their parts. With this, I would like to conclude this chapter live, and soon the chapter 10 will follow you all. Thank you for your patience, this tech, and stay connected.